right, so we're going to look at how to do trig functions of general angles using what we call a unit circle. So let's talk about what the unit circle is first. The unit circle has a radius of 1 unit, hence the name unit circle. I know, they were very creative with that. So if you look, this is a circle centered at the origin, and it's 1 out in all directions. And the idea is, if we make this 1, then let's say I pick a random point over here, x, y, and we have an angle in standard position, so, you know, initial side here, terminal side there that goes through there. The point, if we have a unit circle, this radius is always going to be 1. So any of the fractions for sine, cosine, tangent, when we set these up that have r in them, the r just ends up being 1, which makes the math a little bit easier. So on sine, when we were looking at if you had just a random point on some other circle, it had y over r. Well, if r is just 1, then sine is just the y coordinate for that point. Cosine would just be x. Tangent, because tangent doesn't use r, would still be y over x. But this is a whole lot faster to remember. It's a little bit easier. And then cosecant would be the reciprocal, so 1 over y. Secant would be 1 over x. Cotangent would be x over y. And just keep in mind, if these happen to be some kind of weird fractions, because some of them are, that these just mean reciprocals of whatever that is. Okay? So this makes this a lot more easy to look at. And then I have a unit circle that's filled in. I used to spend a really long time having students use the 45, 45, 90 triangles and 30, 60, 90 triangles to figure out all of these numbers, but in the end it really didn't help them understand very well, so I'll just talk about this a little bit. This is a circle where all the angles are positive. You'll see that we have a lot of our major angles like 30, 45, 60, 90 in degrees. They're also listed in radians next to the degrees, so that's all on the inside of the circle. And then on the outside, using the special triangles that we looked at, the 45, 45, 90, 30, 60, 90, the x and y coordinates have been figured out for each point. So there are a lot of fractions and radicals, but each one of these points would be the point that goes through the angle if it happened to be 30 degrees, 45 degrees, 60. And if you look really carefully, there's a lot of repetition. So for example, let's look at 60 degrees over here is 1/2 square root of 3 over 2. If I go over to this point over here at 120 degrees, it's the same numbers, just the x coordinate happens to be negative. And then if I come down to here to 210, it's the same thing. Well, it's kind of the same thing. They've switched them and made negatives, but there's just a lot of numbers repeating. So there's a lot of repetition. If you memorize the first quadrant, which is not that many numbers, you can actually do a lot of these very quickly, which is how people who ace their ACTs and SATs know how to do these without taking a lot of time to think about it. They memorize these 3 things right here from this quadrant, and then they just know how to change them for everything else. They just memorize a little bit, understand the relationship, and go. So we can use this to answer some questions about the exact value of some trig functions for general angles. So if I want to know the exact value of cosine 135 degrees, so this is exact, not what your calculator is going to give you, but with radicals and fractions, I could find 135 right here and find the point, and cosine is the x coordinate. So I just find the x coordinate, which is the first number, and write down negative square root of 2 over 2. So, and I'll write an x over here. So we found 135 degrees. I have to know cosine is x. Find the x coordinate, and you're done. If you didn't have this, though, then it becomes a little bit more interesting. So if I want to find the exact value of negative 1,020, well, our thing only goes up to 360. So we might have to find a coterminal angle really quick, which is something else that we've talked about. We have to figure out how many times it's going around. So you start with negative 1020, and you want to add 360s until you get to something positive. I think you have to do it 3 times, and you find out that 60 is a positive angle. And I should do this a little differently. Let me grab my calculator really quick, because this is how you would do this quickly. I would put in negative 1020. Okay, it's negative. All of my angles on here are positive, so I'm going to find a coterminal angle that's positive. I'm going to add 360 and go, nope, still negative. Add 360, nope, still negative. Add 360 one more time, and I get 60. So you want to find that equivalent angle that's going to stop in the same position. Find 60. It's cosine, so that means I'm looking for x again. So I'm going to look for the x coordinate of the point where 60 degrees is, and we get 1/2.
Is that it?
That's it. Now, there are some, that's not it for the whole lesson, but for that problem, that's it. So down here on number 3, it says find the exact value of sine squared 5 pi over 6. We haven't really seen this notation. When they put the squared here, that just means you're going to take sine of 5 pi over 6 times sine of 5 pi over 6. So they're giving us the angle in radians. So we're just going to look. Here's 5 pi over 6 over here. Same thing as 150 degrees. If it's sine, I want the y value, so I'm just going to write a little y next to the sine. So that's 1/2. So I'm just going to, I know it's 1/2, but I'm squaring it. I'm going to take it times 1/2, and my answer happens to be 1/4. Ta-da! And it actually explains out here to the side how that works.
So the 5 pi over 6 just goes away?
It's just the angle. Yep. So they're just telling you what angle it is, and then you're going to find that corresponding point. So this is what makes it kind of cool. We're sort of putting in an angle, and we're getting out a value for sine. And then later we're going to see how we can relate these together to make functions you can graph, and it'll be cool. All right, so on number 4, we have 16 pi over 3. If you look, the biggest I have is 11 pi over 6. I have 5 pi over 3. I don't have anything that big. So this is probably something that's off the chart, literally. And it's also in radians. So my first thing that I would do, because I prefer to work with degrees, would be to change this into degrees. So I'm going to do that really quick. 16 pi over 3. How many degrees are there in pi? 180. Okay, I feel like maybe we've forgotten some things. All right, we had Christmas. Get rid of pi's, and then we're going to take 16 times 180 and divide by 3. And we find out this is the same thing as 960 degrees. So if you go a full circle, that's 360. We need to figure out where this is going to land. So using my calculator, I'm going to find a coterminal angle, and I'm going to subtract 360s until I get something that's on the chart. So if I subtract a 360, I'm still too big. 600 is still too big. If I subtract another one, then I get down to 240, and that is on the chart. So you just want to find that coterminal angle, the angle that would be in the same position. This one just goes around twice. It would go around and around again, and it would stop at that 240 place. So here's my point, and they want us to find cosine. So cosine, remember, is the x-coordinate. So once I find the angle, I forgot to write down on this, it was 240. So once I find the angle 240, the x-coordinate is negative 1/2, and that's my answer. So remember that it's the x for cosine. Okay, so if I keep moving, I have to kind of still look at this chart. So it says find the exact value of negative sine of negative 9 pi over 2. So the thing I think that's going to be most challenging is these weird angles they're going to give you that are not on the chart. We have to find them as something that's on the chart. So I would take first and convert this to degrees. So you take it times 180 over pi, cancel out the pi's. You could cancel the 180 with the 2 if you wanted to. Call this 90 and 1. And then I just have negative 9 times 90, which is negative 810 degrees.
So then do we add 360?
And then we add 360 until it becomes positive. Did I do that right? Okay. I'm going to try taking 9 times 180. I had something different on last year's notes, but I think I messed it up last year because this looks like it's right. Okay. I'm doing it right this time. That's what matters. So we're going to take that and add 360s until it becomes positive. So I'm going to take negative 810. I'm going to add 360, which is negative 540. Add another 360. So I'm just kind of writing down. I have negative 90. Negative 90 is not on here, so I have to keep going until it's positive. So I added 360 3 times, and I ended up with 270 degrees, which is something on my chart. It's down here on the y-axis, and so the sign would be the y value. So I'm going to look at the y value, which is negative 1, and then I have this negative here. So I'm taking negative 1, because I have negative 1, but they have a negative in front of the sign. So that just negates it and makes it positive 1. Does that make sense?
So, Ms. Fillmore?
Yes.
Since, even though it was negative... Never mind.
Okay. So the angle's negative, but we found a positive angle that lands in the same place. So that gets rid of this negative. And then this negative is just in front of the whole thing. So once we did this part, that's negative 1. And then I changed the sign because the other negative is in front.
Okay,
I know, it's a lot of minus signs.
Okay, no, I'm still going to ask. Okay,
Okay.
So whenever we were adding 360s, we
Yes.
got to negative 90. Could
Yes.
we not use, would it not be the same thing? Even though
Yes. So if you know that negative 90 is down here, you could go to that point.
Oh,
Yes.
Okay.
What I'm trying to do is show you with the degrees that are labeled how to do that. But yes, if you know how to read the negative off this chart and you can find it more directly, you are welcome to do that. So she's asking us when we got to the point where it's negative 90, she knows negative 90 is down here. Can't she just go ahead and use it? Yes, you can. But I've had in the past people that got confused when I did that. They're like, negative 90 is not on the picture. So I'm going to go ahead and keep going until it's one of these, just so you can see. I'm just trying to be thorough. Okay, so basically keep going until you can find that angle on the picture and then use the point. All right, so number 6, it has find sine of negative pi over 3. So negative pi over 3, you could, in theory, do this. So if I see that pi over 3 is up here, if you're really good, you might theorize that, okay, it would be this one down here and go from that. So if you enjoy that, that's okay. But I think most of my students, when I've tried to teach it that way, got confused.
No, I like that.
But if you like that, that's okay. What I try to do when I teach this is we convert it to degrees and make it an angle that we can see on the chart, and then it goes forward. So I have negative pi over 3. I'm going to go ahead and convert it to degrees just because some people will be more comfortable when I do that. So I end up with negative 180 over 3, which gives me negative 60. So some people are going to get to this point and go, okay, I know that negative 60 is the same thing as 300, and that's my point right there. You could stop there and get the point. Some people are still confused if it's not on there. So you could keep going and go, okay, negative 60 is not on my chart. I'm going to make it positive, so it's something on the chart. I'm going to add 360. My coterminal angle is 300. 300 you can easily find on the chart and find the points. And then it wants to know sine. So sine would be the y value. And I just go down to that, and it's negative square root of 2 over 2. Okay. And then we actually get to do a cotangent and a tangent. I saved the best for last. You may not be completely convinced of that. All right, so...
Wait.
Yes, question?
My headphone hurts.
I'm sorry. Why is what not...
Dude, what? Why is it not
Okay, so we changed it to 300 degrees. Were you okay?
I think you looked at the chart wrong.
Okay, so 300's right here. It's this point. This is what goes at that point. And we wanted the y value.
No, what does that go with the one above it?
Oh, I was looking at the wrong one. So it's negative square root of 3 over 2. She is right. I was looking at the wrong thing. So good job.
That was annoying.
So that was, so the chart is a little interesting to read. So that was for this point. This is for that point. She's not wrong. Okay, so now are we all good?
Yes.
All right, so going on to number 7. It's cotangent. First of all, cotangent is the first one. We have to do x over y. Cotangent and tangent are a little bit more interesting because there's actually going to be some actual fraction action happening. Okay? Okay. So the first thing we're going to do is, I have this in radians and it's really big. It's not something that's on the chart, so we're going to do some converting. So I'm going to take 20 pi over 3 and convert it to degrees really quick. So we'll take it times 180 over pi, cancel the pi's. And if you wanted to cancel 180 with 3, that would give you 60 and 1. And then I just have to take 20 times 60, which is 1200. So 1200 degrees is way off the chart. Our chart goes to 360. So what do we do to find a number that's on the chart?
Subtract 360.
Subtract 360 till we get something that's on the chart. So we're going to take 1200, subtract 360, and we're still not on the chart, so we're going to subtract 360 again. We're getting closer. We're still off the chart. Subtract 360 one more time, and now we are on the chart. 120 I can find. So I'm going to go to 120. And 120 is up here, and here's my point, negative 1/2 and square root of 3 over 2. I'm going to copy that down here. My point is negative 1/2 square root of 3 over 2. This is my x value. That's my y value. Okay?
That is the worst thing.
So when you see this x over y, if I actually write it as a fraction, it's going to be confusing. X over y means the same thing as x divided by y. So what we're going to do is we're going to take negative 1/2 divided by square root of 3 over 2. So we have to think about, gee, how do I divide fractions? Copy dot flip is one method. Invert and multiply is another method. So you make it negative 1/2 times 2 over the square root of 3. And the 2's are going to cancel out. This 2 and that 2 go away. I have negative 1 over the square root of 3. And if life were fair, we would stop there. But we can't leave radicals in the denominator, so then you just keep going. Multiply by the square root of 3. And we end up with negative square root of 3 over 3 as my final answer.
Can't that just be 1?
No, because this one's under a square root. They're not the same. I know.
You're off the...
I'm sorry.
That's not real.
There we go. So this is why we spent so much time on radicals, so that hopefully that's not the part that screws us up. And we spent time dividing fractions.
Joke's on you, I can't even get to that point.
We're going to do another one.
Do you want a strip of textured paper?
No, thank you. All right, so let's look at number 8. So number 8 is tangent. When we're looking at our formulas, tangent using the unit circle is y over x. We can also think of that as y divided by x. This is going to be a little easier for us to use if you already have fractions. We don't want to put fractions inside of fractions. That's going to make this easier. Start with the strange angle that we have. Let's convert it to something that we can use. So we have negative 23 pi over 6. Let's change that to degrees. So times 180 over pi. Cancel out the pi's. And I can also reduce 180 with 6. That makes this 30 and 1. You can multiply and divide if that makes you happier. Not sure. Okay, so we're going to end up with negative 690. At least it's in degrees now. We don't have pi's. It's a little easier to work with. So I have negative 690. What are we going to do with it?
Add 360.
Add 360. It's still not positive. So we're going to do it one more time. and then it's going to be nicer. It's just 30 degrees. So then I'm going to go up here to 30 degrees. 30 degrees is this point over here, square root of 3 over 2 and 1/2. I'm going to copy that down here just so that we have that to look at. Square root of 3 over 2. I am off the page. And I lost my place, 1/2. So this is my x, and this is my y. To do tangent, I want y divided by x. So we're going to do 1/2 divided by square root of 3 over 2. So copy dot flip or invert and multiply, whatever your favorite fraction phrase is. We're going to change it to multiplication, flip this over, and it's going to look basically like what we had the last time, except it's positive. So we just do a quick rationalization of the denominator, and we end up with square root of 3 over 3 as your final answer. One of the things that will freak a lot of people out is a lot of your answers are going to look the same. And that's just what happens because there's a limited number of angles that we're looking at. It's just how it happens. All right, so let's take a look at number 9. Number 9 says find the exact value of secant 3 pi over 2. Guess what? 3 pi over 2 is already, on the graph. Yes.
Okay, so I messed up and I worked hard, but I copied and dotted and flipped the wrong. I did the 1/2, and I got a wrong answer. So you have to do the one with the radical.
So basically, you copy the first number, you change this to multiplication, and you flip the second fraction. You always flip the second one.
Where is your fraction?
You always flip the second one. What that number is just depends on what point you're doing.
Yeah, I set it up wrong.
Okay,
Yeah.
so number 9 is actually easier than what we just did. Secant is 1 over x, and 3 pi over 2, thank goodness, is just on the chart. We don't have to do anything except look it up. So 3 pi over 2 is down here, and we need the x value because it's 1 over x. The x value is 0. So I'm going to have 1 over x, which is 1 over 0, which is undefined, and that is your answer. You don't have to do anything else with that.
Okay.